Good day, sir. My name is Melanie Ramabon from BSIT4A. My topic is Centroid-Based Clustering. Centroid-Based Clustering K-means algorithm is one of the centroid-based clustering algorithms. Her K is the number of clusters and is a hyperparameter to the algorithm. The core idea behind the algorithm is to find K centroids, followed by finding K sets of points which are grouped based on proximity to the centroid, such as the squared distances of the points in the cluster to the centroid are minimized. This optimization is a very hard problem, hence an approximation is used to solve the problem. So, centroid-based clustering organizes the data into non-hierarchical clusters. In contrast to hierarchical clustering, defined below, K-means is the most widely used centroid-based clustering algorithm. Centroid-based algorithms are efficient but sensitive to initial condition and outliers. This course focuses on K-means because it is an efficient, effective, and simple clustering algorithm. The implementation of centroid-based clustering first is select K points at random as centroid or cluster centers. The second one is assign data points to the closest cluster based on educational distance. The third is calculate centroid of all points within the cluster. The fourth is repeat iteratively converges. Same points are assigned to the clusters in consecutive iteration. So the only problem with this implementation is, however, is that it suffers from initialization sensitivity. On selecting different centroids in the initialization stage, different clusters are generated. So workaround to the problem would be, first is to repeat the K-means multiple times with the different initialization and select the best result. The second one is to repeat K-means multiple times with different initialization and select the best result. And the last is, instead of using random initialization, to use a smart initialization process such as K-means plus plus. In some cases, it is difficult to interpret centroids. For example, if you are dealing with the text data, centroids are not interpretable. An approach to deal with this would be use the K-methods algorithm. It would be to use the K-methods algorithm. It would select the most centered member within the data as a cluster center and generally more robust to outliers than other means. You may wonder how is the very value for K is selected. Elbow or knee method is used to determine the best K. We try the K-means implementation for multiple K values and plot them against our sum of square distances from centroid loss function. The elbow of the curve where the curve visibility bends is selected as the optimum K. The advantage of centroid-based clustering using K-means first is the algorithm in most cases runs in linear time and simple and intuitive to understand. And centroid-based clustering is we have a limitation using a K-means. The first is a number of clusters need to be known beforehand. Second, it is not very robust to outliers. 3. Do not work very well with the non-verb shapes. And the last is tries to generate equal size clusters. So, the example of centroid-based clustering is here. Where is the we have a shape of circle, triangle, square. Where is that is the center of the dots. And we then fit our data to the K-means clustering models as implemented by scikit-learn. We have used for our initialization method to be K-means plus plus instead of random and set our K to be 3. That's all. Thank you.